Today we're doing our second day of section 1.1. We are going to be solving equations using multiplication and division. Okay, so we did addition and subtraction already. You should have practiced that yesterday. Today we'll move on to multiplication and division. For our warm-ups, number one, we have 3 times 4/3. What did we get?
I got 4.
4. Any other options? We should not have gotten any other options. We could put the 3 over a 1, multiply straight across the top, 12 across the bottom, 3 reduces to 4. Or you can cross cancel those 3's to get there a little quicker. Number 2, what did we get?
It's the same thing. They say the same.
What do you mean?
Like, it's 3t divided by 3.
But that'll simplify. Austin, what'd you get?
T equals 1.
Ooh, that's not an equal sign in here, so we won't throw an equal sign in there. Unless it's just to say that we're simplifying this to equal something.
1 and 2.
1t. Okay, so we were on the right track there. 3t divided by 3 is just a t. We don't know what t equals as far as a value goes. We just know that that simplifies to a t. Now, number 3 is different because there's an equal sign in it from the beginning. So on number 3, we solve it like we were doing on Friday. What is it that we're trying to get alone? Okay. We can break up our equation with a line if we want to. What do I need to do to both sides? Subtract 8. Now this is where it got a little tricky for some people. We have negative 10 minus 8. Negative 18. Questions about our warm-ups? All right, much like last week when we did our other properties of equality, you need to know the title of it, and you need to have the algebraic version of it. You do not need to write all the words. The multiplication property of equality states that multiplying both sides of an equation by the same number produces an equivalent equation. So in this case, they used the x to represent times. So A times C, B times C. The division property of equality, same thing. We should have a title for it. We need to have the algebra down. You do not need to write out all the words. But it says that dividing both sides of an equation by the same non-zero number produces an equivalent equation. So it might be helpful to add in that C cannot equal 0. We cannot divide by 0. When I was in high school, the way that I was taught this was NO. We should not, no, have a 0 on the bottom. But it is okay to have a 0 on the top. Okay, so a 0 on the bottom is a big NO, but it is okay for 0 to be on the top. All right, we're jumping into our examples. So again, when we solve, our goal is to get the variable alone. You don't need to rewrite this goal. We talked about it last week. Get the variable alone. So our answer should always be x equals a number, or the variable equals a number. All right, on number 1, what's happening between the 8 and the x right now? We're multiplying. What operation will undo multiplication? Division. So again, we can box in our variable and split up our equation if it helps. You have to show me that you are dividing both sides by what number? 8.
Shouldn't it be a negative though? The other one a positive at the top.
What?
Shouldn't it be a negative? It's a positive. It's a positive 8 at the top.
No. So we divide by exactly what's being multiplied. So if we're multiplying by a positive 8, we divide by a positive 8. So that way we don't change the sign. Now on the other side, we've got a negative divided by a positive, so our answer will come out negative. And if we take 756 divided by 8, what do we get? Negative what?
94.5.
94.5. Okay, if you put negative 94.5, that's fine. If you left it as a simplified improper fraction, technically that would be okay. This is probably the easiest answer to get to, especially if we're using our calculators. All right, on number 2, what are we trying to get alone?
5.
We're trying to get the x alone, which means we need to move the 5 by using division. Divide both sides by 5. That means 5 over 5, those cancel out, leaving us with an x. And 75 divided by 5 is 15. All right, on number 3, what did we do to get x alone? Divide by what? Good. You divide by whatever it is that's by x. So in this case, that's a negative 25. So we've got 275 divided by negative 25. What do we get? Negative 11. Again, if you want to write it as x equals negative 11 instead, that's fine. But the 11 should have a negative sign on it either way. On number 4, wow, what did we do? How did we get k alone? Divide by negative 4. And what did we get for k? 0, good. So it's fine for 0 to be on the top. We divide by a negative 4. 0 divided by negative 4 is still just 0. Again, if you prefer your 0 to be on the other side of the k, that's fine. Same thing. 5 and 6 are a little bit different. On these, we are starting out by dividing. So what do we need to do to undo division? Multiplication. So to get h alone, we multiply both sides by 5. On the left side, those 5s reduce or cancel each other out. That was the whole point, was so that h would be left alone. 17 times 5 gives me 85. On number 6, how are we getting w alone? It's being divided, so to undo it, we multiply by 2. Good. Okay, so what do we get for w? Negative 16. Again, I don't need you to box the variable and put the little line unless you want to. You do need to show me what you're doing on both sides of the equation every time. And I would highly recommend boxing or circling your final answer so that I can find it. Questions, concerns? We'll keep it moving. Give you a moment to do these. On number 8, if you want to give the negative sign to the 2 in the denominator, you can do that. That makes it easier. So if you want to rewrite it as 7 equals u over a negative 2, that's the same thing. Okay, we still only have one negative sign written there. What did we get on number 7?
I got
8 equals negative 48. How did we get that?
You gotta multiply negative 3 and 6.
Good. Multiply both sides. Multiply both sides by a negative 3. A equals negative 48. Make sure you are multiplying or dividing by whatever number is there already. So don't be changing the sign with what you're multiplying or dividing by. Number 8, what did we get?
14.
A negative 14. How did we get there?
Times negative.
Good. Multiply both sides by negative 2. So we get negative 14 equals U. Jasha?
That was the restaurant.
I got a question.
All right, this example looks a little bit different, but our goal is the same. We are trying to get this x alone. So our goal is still to get x alone. So what is it that we're trying to move?
When we get, what's the name?
Anyone know? Pi. We're trying to move the pi. So right now we're taking pi times x. So how do we undo multiplication?
Divided by 5.
Divide it by pi. And if we do it to one side, we do it to the other. So the pi's cancel out, leaving us with an x. But on the other side, what's going to happen to the pi's? They're going to cancel out too. And what are we left with?
9.
A 9. So yes, you could write it as x equals 9 instead if you would like. Questions, concerns? Dominic?
Will we see these either in our textbooks or on our worksheet?
Yes, it is possible to see problems like this in the textbook. I think this is one of the examples from the textbook. Anything else? Okay, we'll keep it moving. All right. When a fraction is attached to a variable, just multiply by the reciprocal on both sides. Of course, that should be assumed when we're solving equations, but I'll add it in there just in case. So down there, a reciprocal is a multiplicative inverse. That's all fine and dandy, but I'm going to write something different for reciprocal. How do we remember what a reciprocal is? For example, if I want the reciprocal of 2/3, what is it? Three over 2. So those are reciprocal. So I want you to remember that the reciprocal is when you flip a fraction. So you don't really need to write the multiplicative inverse definition of it. It's true, but I think it's more useful for us to just remember that a reciprocal is the flip of a fraction. So the reciprocal of 2/3 is 3 over 2. All right, so on example 10 and 11, we can see we are multiplying our variables by a fraction. So we're going to use that rule from the last slide. So there's a fraction attached to our variable. We're going to multiply both sides by the reciprocal of that fraction. So
Will be 7 over negative 2.
good. So this reciprocal there is 7 over negative 2. That's the one that we use on both sides. To make it a little easier on myself, I could put that negative 14 over what number?
1.
A 1. Okay, so on the left side, those fractions totally cancel each other out, and that was the whole purpose of it. So those 7s cancel, the negative 2s cancel. That leaves me with just my A. That's what I wanted. On the right side, you can go about it a couple ways. You can take negative 14 times 7. What would that give me?
Negative 98.
Negative 98 over 1 times negative 2. Negative 2. But I'm not done because now that can be simplified or reduced or divided. So what do we get for A? 49. So a negative divided by a negative is a positive. 98 divided by 2 is 49. All right, on number 11, it might be useful to just give the negative sign to either the 13 or the 7. You get to pick, but it can only go to 1. So which one do you want to give it to?
I'll probably
Give it to the 7. Okay, so I'm going to take it away from the front, and I'm just going to put it with the 7. We still just have one negative sign there. We didn't give it to both. We only had one to use. We gave it to the 7. What am I going to multiply both sides by? Good. Negative 7 over 13. And I'm going to put the 39 over a 1. Trying to get x alone. On the left side, what happens with my fractions? They cancel out totally, leaving me with x. On the right side, you could cross cancel here. What would cross cancel or cross reduce? The 39 and the 13. What could the 39 become?
3.
A 3, and the 13 would become a 1. So it might help if you can see your cross canceling earlier on. If not, you'll just have to simplify at the end. So now I'm taking what times what to get my answer?
1 times negative 7.
3 times negative 7 gives me
They're gonna be negative 10.
negative 21. And then in my denominator, I would have what times what?
1 times 1.
1 times 1, which is 1. So I'm fine if you just write your answer as negative 21.
Okay.
If you leave it over the 1, it's not wrong. But usually you will not see that 1 in the denominator. Questions, concerns? What did we multiply both sides by? Negative 10 over 1 would work, or you could have it as 10 over negative 1. Either way, the 5, again, put over a 1 if it's a whole number. So here, negative, negative, those cancel out. So do the 1s, so we just have an R. And then on the right side, 5 times negative 10 gives us that negative 50. Again, if you put it over 1, fine, but usually you won't see that.
Ain't negative 1 over 2 the same thing as negative 50?
You didn't flip your fraction when you multiplied on the other side. We got to flip this fraction. Okay. Make sure you're doing the reciprocal on both sides, not just the same fraction. If you do the same fraction on both sides, you're not helping yourself out. Deshaun? Answer number 13? What'd you get?
I got x = 125.
X equals 125. Anybody else? I hope you did get that because that sounds right to me. So we're trying to get x alone. So we are multiplying both sides by what? 5 over 1. So we multiply both sides by 5 over 1. That's the same as multiplying by 5. And even though there wasn't really space for me to put the 5 over 1 by the other fraction, it still works the same where they're canceling each other out. And we should have 125 equals x, or x equals 125. Questions, concerns? Okay, let's keep it moving. we've got a couple application problems to wrap us up here. So again, with the application problems, I am not expecting you to write all the words. We're going to read through it and write down the important information that we want to use. All right, in the 2012 Olympics, Usain Bolt won the 200-meter dash with a time of 19.32 seconds. Write and solve an equation to find his average speed in meters per second. Round your answer to the nearest hundredth. Hint, use D equals RT. If that equation is not familiar to you, that means distance equals rate times time. So you will need to write down D equals RT. And it might help to write distance equals rate times time. All right, so when we solve this, especially when we're given a formula like distance equals rate times time, it would be useful if we knew certain things about this. Do we know the distance that he ran?
Yeah.
What is it? 200 meters. They told us it was a 200-meter dash. So 200 meters. His rate. Do we know his rate? Did they tell us how fast he ran? No, that's what they're asking us to find. His average speed. That's another way of saying his rate. So if we don't know it, what are we going to call it?
R.
R works for me. We don't know it, we give it a variable like R. His time. Did they tell us how fast he went? It took him how long? 19.32 seconds. So now we're just going to plug this stuff into the formula that they gave us. And then we can solve it. So write and solve an equation. My distance, or D, is 200 equals, I don't know my rate. My time was 19.32. What do I need to do to get my R or my rate alone?
You gotta combine 200 and 19.32 to get R by itself.
We're going to do what? What operation?
Division.
Division. We have to divide by 19.32 on both sides. Calculator is definitely going to be essential on this one. I mean, not totally essential. Technically, you could do it, but it would probably take most of us a while. What'd you get, Hunter?
The answer?
Yes.
10.30, or 10.4 goes.
We're rounding to the nearest hundredth. So what came after the point?
4,
Nope, give it me the original.
3,
And then
5,
and then after the 5?
4.
Okay. So if we got 10.351 and they say round to the nearest hundredth, that's 2 places after the decimal. So for my final answer, the 1 is going to do what to the 5? Make it go up or stay the same? Stay the same. So if we were going to the 10th place, Hunter would have been right. The 5 makes the 3 go up. But we wanted the 100th place. Okay, and that would be meters per second. Questions, concerns about that first one? All right, next one. Suppose Usain Bolt ran 400 meters at the same average speed that he ran the 200 meters. How long would it take him to run 400 meters? So this time, what is it that we're looking for? Distance, rate, or time?
I think time.
Time. It said how long. So, again, the distance, what is his distance this time? 400 meters. His rate, what rate are we using?
It was 200, I think.
they're changing the problem. Our distance is now 400 meters. So we're changing it to 400 meters, but it's saying at the same average speed that he ran the 200 meters. What was that average speed or that rate?
400.
No. Those are both distances, not rates. What was the rate that we just found?
Oh, we're gonna use that.
It said the same average speed. This was his average speed. So 10.35 is his rate. It said the same average speed. That means the one we just found. Meters per second. The time is what we don't know. So what variable do you want to use? T makes sense to me. So again, we plug in what we know. The distance was 400. The rate 10.35 times T, because we don't know the time. What are we going to do to solve for T?
10.35 on each side.
Divide both sides by the 10.35. And what do we get for T?
Yeah, 38.647.
38.637?
647.
647. Okay, so they again say round to the nearest hundredth. So our final answer is going to be 38 point what? 65, and our units seconds. Now, this should sort of roughly make sense. How do the distances from the first problem and the second problem compare to each other?
No, go back to
How can we take 200 and make it into 400? We multiply it by, times it by 2. And if his rate didn't change, then we would expect that his time would roughly get multiplied by 2. And this time is roughly twice his last time. So we can go back and check and say this kind of makes sense that it would turn out this way. Homework is on pages 8 and 9 again. We're in the same section. Homework is still out of the book, pages 8 and 9. This time we are doing numbers 1 through 4. The group from 21 through 29, you're doing the odds just out of that section. And then 33, 37, 41, 43, 47 individually at the end.